All right, let's get started. We're going to do a little bit of a math brush up here. This is stuff you've probably seen, maybe even could be boring, but it's basically the height of the math that we'll get to during the quarter. So it's probably good just to kind of go through and, like I said, brush up a little bit. So one thing, this is something that, again, you've seen somewhere, but people can be a little bit rusty on. And so it's multiplying powers of something. And so here, what is 3 to the second power times 3 to the third power? What does that equal? So maybe pause, give yourself a second, and see what you think, and we'll come back and discuss. Okay, and hopefully you got this answer right here. And so basically the way that this works is the rule of thumb is if I'm multiplying, 3 squared and 3 to the third, what you do is you add the exponents. So it's 3 to the fifth. And so that's just kind of a rule of thumb. You can actually, write this out, 3 times 3, and then times 3 times 3 times 3 is going to be the same thing as 3 times 3 times 3 times 3 to the fifth power, right? So it works out the same. Break out your calculator, check it out. Again, it's the kind of thing that, again, on a test, you can always use your calculator, but it's just kind of nice to be able to kind of go through something like that kind of quickly. All right, now probably the primary type of math that we'll do is units and converting units. And so, we're going to work in this class with things that we'll need to quantify. And so when we measure stuff, we need units. For us, we'll have some sort of fundamental units of length, mass, and time. And then often we'll have units that are combinations of these. Like, for instance, speed is length divided by time. For us, we're going to use what's called the SI system, which is sort of abbreviation for System International. So this is the set of units that we're going to use. And so for us, sort of our favorite units will be the meter for length, kilogram for mass, and seconds for time. And it'll be often that you'll need to convert these units, or at least, the book. Unfortunately, different organizations, different people use different units, and so basically the biggest, I think, brunt of our math will be converting units around. One popular one is the British units, which we use here in the United States a lot: inches, feet, miles, pounds. So again, we'll use the SI units, but we'll need to sort of convert back and forth. So doing math for units, how do we treat units when we apply math to our numbers? So addition and subtraction, the way that works is you have to have the same unit. So if I'm adding up here, it's a speed, 4 meters per second plus 5 meters per second. To get 9 meters, they need to have the same units. It doesn't make any sense to add a speed to a kilogram. Now, what we'll use probably more often is multiplying different kind of units together. And basically, when you multiply units, you treat them just like algebra. And so here I've got, this thing, 4 meters per second times 5 kilograms per meter. And what I do is I can cancel out the meters on both sides, and then I get 20 kilograms per second. And so that's something that we'll do. But more often what we'll do is we'll use that to convert between different kinds of units. So how do we change from units to units? So for instance, how do we go from meters to inches? What we do is we multiply by what I like to call a number 1. Right? We can multiply anything by the number 1 and it stays the same. But in this case, we'll pick a very special number 1. So for instance, let's say we want to convert 3 inches into centimeters. So we start with 3 inches and then we multiply 1. Okay, so what 1 do we want? We're going to go here. So the book has conversion tables. You also find them online. And so here, to get from inches to centimeters, we want to do inches into centimeter conversion. So 1 inch equals to 2.54 centimeters. So when I write it here, 2.5 centimeters divided by, and technically you'd say 1 inch down here, that's 1, because they're the equivalent, so they're the same exact thing. And so we're multiplying by 1, so we're not changing our number, we're just changing sort of what units we use. And then here, just like before, what we can do is cancel out the inches, just like algebra, and then the 3 times 2.54, we get 7.62, and that comes out to be centimeters. And so that's how we convert 3 inches into 7.62 centimeters. Inches cancel out, and again, since we only multiplied by the number 1, the number is actually the same, just in a different set of units. All right, and so let's look at another example. This is one that we're going to use a ton. How many seconds are in 1 hour? So what I'll start with is 1 hour. And then what I'll say is, okay, so that's equal to 1 hour. And then now I'm going to move this over and convert. So what do we know? Well, we know that in 1 hour there's 60 minutes. And so I write 60 minutes over 1 hour. And I write it this way. Well, I write this way because I want the hours to cancel. And so what this says is 1 hour is equivalent to 60 minutes, which, no big news there, but that's just sort of how we do this. Now, to get this into seconds, the next thing we want to do is we want to use minutes and seconds. And so I'll do this. 60 seconds is equivalent to 1 minute. And again, why did I put the minute on the denominator, the downstairs? Because I want it to cancel. And so now we look at this here. So it's 1 times 60 times 60, all divided by 1s. 60 by 60, if you put that in your calculator, is 3,600. Now look at the units. All the units have canceled except for the seconds. And so here's a really useful conversion that we'll use a ton, which is 1 hour is equivalent to 3,600 seconds. All right, so let's again try one. So maybe pause and give this a try. So we want to convert 1 mile per hour into meters per second. And then over here, I basically have all of the different conversions that you might need. So let's give that a go, see what we come up with, and we'll come back and discuss. Okay, hopefully you got answer A here for this one. And let's look at this. So again, converting 1 mile per hour into meters per second. So how are we going to do that? Well, I'll go over here and I'll start so this will be 1 mile per hour. And so that equals 1 mile per hour. And so you can go different orders, but I'll start here using this one here. And so I'll write out 5280 feet in 1 mile. And so I cancel out the mile, and so now I've got that equals to 5280 feet per hour. Okay, so we're getting there. And now we want to get to meters. And so for meters, I'll use this conversion here. And so 1 meter is 3.28 feet. Again, I want the feet on the denominator so it cancels out. And so now I've got, my units would be miles per hour. So I'm getting closer. And finally, we use this one we just kind of developed. 1 hour equals 3,600 seconds. We couldn't go through in minutes and seconds, but it's just, you can save yourself a step here. And so what I want with hours on the denominator, so I want it to be up top. So 1 hour divided by 3,600 seconds. And so then the hour will cancel the hour. Okay, and so the units, the only ones left standing are meters per second. And when I go through and do this, I got 0.447 meters per second. So interesting note that 1 mile per hour works out to be about a half meter per second. But again, just a kind of example of something that we might do to get units back and forth like this. All right, and another thing, again, you've probably seen, is scientific notation. And basically, we're going to deal in this class a lot with either very large numbers or very small numbers. And so it doesn't make much sense to write it out with a whole bunch of zeros. And so we've developed this thing called scientific notation to make things a little bit easier. And so here, to convert a number into scientific notation, and so in this case here, we're converting this number 6,370,000 meters, and we write it here as 6.37 times 10 to the 6th meters. And if you look at this number, the way that this works, so again, this number is 6370000. And what we do is we start sort of over here and just look at how many times we have to move over. So 1, 2, 3, 4, 5, 6. And so 6, and so 6.37 times 10 to the 6th. And so this is the way that we'll typically write a number like this, just to make life a little bit easier. And then so when it's 10 to the 6th, that means this number is actually bigger than 6.37 by 6 decimal places. Now, alternately, if we have a number like this is another really annoying number to write. And so here we got 1, 2, 3, 4, 5, 7, 5 meters. And so here what we do is we write it, and again what I do is I do 1, 2, 3, 4, 5, 6. So 6 steps, but the other way. And so it's 7.5 times 10 to the negative 6 meters. And again, I sort of stop when I've got the number. Typically we do this when we got the number down to like a single digit, so like 7.5, 9.8, something like that. And then here, 7.5 times 10 to the negative 6 means that the real number is smaller than 7.5. And it just works out easier to sort of do this than writing these huge numbers or really small numbers all the time. Okay, so let's try one here. Go ahead and pause this. And so we want to know is write the following number in scientific notation. So which one of these is the following number in scientific notation? And the number we want to write is 364. Okay, give this a go and we'll come back and discuss. Okay, hopefully you got A from this. And so I'll just do a couple. So 3.64 times 10 to the second. In this case here. And so let's go back and look at this one. And so what does that mean? Well, it means I take 364, and so it's times 10 to the 2. I start here and go 1, 2. And so that does work out to be 364 as we expected. If we take another one, like for instance, this one here, 36.4 times 10 to the negative 1. Well, what does that do for us? Well, that takes 36.4. And if it's negative 1, we move it the other way. And so this would actually be equivalent to 3.64, which again is not what we're looking for. And the same sort of thing here. So like this one here, 3.64 times 10 to the negative second. What would that be? Well, we'd have 3.64, and we move it 1, 2. And so this would be 0.0364. Again, not what we're looking for. So so again, hopefully this makes sense. And so it's just, again, these numbers will oftentimes be easier to write this way. And then the last thing that we should discuss as far as units go are these prefixes. And so again, another sort of example. So we had maybe you can write some number like 3.64 times 10 to the 6th meters. Okay, so that's a scientific notation that beats writing 3, 6, 4 and a whole bunch of zeros. But what you can do is even write that even more condensed by using one of these prefixes. And so right here, mega is the prefix for 10 to the 6th. And so for this number here, it's equivalent to write it 3.64 megameters, where I'm using this M here to write that. And so it's the kind of thing where a lot of times when we come across numbers, it'll be written this way just to be easier. It's easier to write a big M than it is to write times 10 to the 6th. And so it's just, when we do have occasion to have to work with these units, we'll need to kind of, convert them back and forth. And so let's try one here, which is, I guess, kind of a tricky one. So use common prefixes. Okay, and we want to figure out, so we got 3 options, A, B, and C. Which one is equivalent to writing 0.0038 grams? So which one of these is equivalent to writing that? So go ahead, give that a go, and we'll come back and discuss. Okay, and hopefully you got answer B. And so let's look at this. So for answer B, we've got 3,800 micrograms. And so we go to our chart, 3,800. And what's micro? Well, micro, so again, it's this guy here. This is 10 to the negative 6. So this is times 10 to the negative 6 grams. And so that's what this number is equivalent to. And so now we want to see, okay, so what does that equal for this guy? And so what I take this number then is, so 3,800 and then times 10 to the negative 6. So I start here and I go 1, 2, 3, 4, 5, 6. So to write that, I got to write 2 zeros for those 2 leading ones there, and that would be grams. So it's 0.0038 grams, just like we were kind of hoping for. And so hopefully you can see that the other ones do not work out. So 3.8 centigrams, and that would be 3.8, and then centi, we go over to here. Right here is 10 to the negative 2. And so then to write that, I would write 3.8, and then I'd write 1, 2. So it's close, but it's 0.038 instead of 0.0038. So not exactly there. And then the last one, so we'll write 38 milligrams. And so it's 38, and I go over here for milli. It's right here, 10 to the negative 3 grams. And then, of course, how do I do that? Well, I write the 38, and I go 1, 2, 3. So it's 0.038 grams. So it's the same one we just did, but again, it's not the one that we're looking for. Okay, thank you so much. Hope that helps, and we'll see you in class.